Motor starters are generally employed for motors that are rated at 1 horsepower or larger when operating at 120 volts or 240 volts. A motor starter is an electrical device used to provide controlled starting of electric motors. It includes overload protection and often other protective functions. Direct online starters are the simplest type, applying full voltage to the motor windings. They are suitable for small motors that can withstand the inrush current. Reduced voltage starters, such as autotransformer starters, reactors, or part winding starters, are used to limit the inrush current during startup. They apply a reduced voltage to the motor initially, gradually increasing it to full voltage as the motor accelerates. Variable frequency drives offer the most sophisticated control, allowing for smooth acceleration, speed adjustment, and energy savings. They control both voltage and frequency to the motor. Cross-the-line starting, also known as direct online starting, is a method of starting an electric motor by applying full line voltage directly to the motor terminals. This method is simple and inexpensive, but it can cause a large inrush current that is several times the motor's full load current. This high inrush current can cause voltage dips in the power supply, which can affect other equipment connected to the same circuit. It can also cause mechanical stress on the motor and driven equipment. Reduced voltage starting methods are used to limit the inrush current during motor starting. These methods reduce the voltage applied to the motor terminals during startup, which reduces the inrush current. Common reduced voltage starting methods include autotransformer starting, reactor starting, part winding starting, and Y-delta starting. Autotransformer starting uses an autotransformer to reduce the voltage applied to the motor terminals during startup. The autotransformer is tapped at different voltage levels to provide a reduced voltage for starting. Once the motor has reached a certain speed, the autotransformer is bypassed and full voltage is applied to the motor terminals. Reactor starting uses a reactor in series with the motor windings to reduce the voltage applied to the motor terminals during startup. The reactor is an inductor that provides a voltage drop, reducing the voltage applied to the motor. Once the motor has reached a certain speed, the reactor is shorted out and full voltage is applied to the motor terminals. Part winding starting is used with motors that have 2 or more identical windings. During startup, only one winding is energized, which reduces the voltage applied to the motor. Once the motor has reached a certain speed, the other winding is energized and full voltage is applied to the motor terminals. Y-delta starting is used with motors that are designed to be connected in a Y configuration during startup and a delta configuration during running. During startup, the motor is connected in a Y configuration, which reduces the voltage applied to the motor. Once the motor has reached a certain speed, it is reconnected in a delta configuration, and full voltage is applied to the motor terminals. A motor starter is an electrical device that starts and stops an electric motor. It also provides overload protection for the motor. A motor starter typically consists of a contactor and an overload relay. The contactor is an electromechanical switch that connects and disconnects the motor from the power supply. The overload relay is a protective device that senses the motor current and trips the contactor if the current exceeds a certain level. Motor starters are available in a variety of types, including manual starters, magnetic starters, and solid-state starters. Manual starters are simple starters that are operated manually. They are typically used for small motors. Magnetic starters are starters that are operated by an electromagnet. They are typically used for larger motors. Solid-state starters are starters that use solid-state devices to control the motor voltage. They offer smooth starting and stopping and can be used for a wide range of motor sizes. When selecting a motor starter, it is important to consider the motor voltage, horsepower, and the starting current. The motor starter must be rated for the motor voltage and horsepower. The motor starter must also be able to handle the motor's starting current. The National Electrical Code, or NEC, provides guidelines for selecting motor starters. NEC Section 430 covers motors, motor circuits, and motor controllers. It provides requirements for motor overcurrent protection, motor overload protection, and motor control circuits. NEC Table 430.52 provides maximum ratings or settings for motor branch circuit, short circuit, and ground fault protective devices. This table helps determine the appropriate size of circuit breaker or fuses to protect the motor circuit. NEC Section 430.83 covers motor controllers. It specifies the requirements for motor controller disconnecting means, motor controller overload protection, and motor controller short circuit protection. When installing a motor starter, it is important to follow the manufacturer's instructions and all applicable electrical codes. The motor starter should be installed in a dry, well-ventilated location. The motor starter should be properly grounded. The wiring connections to the motor starter should be tight and secure. Troubleshooting a motor starter typically involves checking the power supply, a control circuit, and the motor itself. Firstly, verify that the power supply to the motor starter is energized and at the correct voltage. Use a voltmeter to check the voltage at the line terminals of the starter. Secondly, check the control circuit for any open circuits or short circuits. This may involve testing the control wiring, push buttons, and other control devices. Thirdly, inspect the motor for any signs of damage, such as burned windings or a seized rotor. Use an ohmmeter to check the motor winding resistance. Motor starters are essential components in many industrial and commercial applications. They provide controlled starting, stopping, and overload protection for electric motors. Understanding the different types of motor starters and how to select and install them properly is crucial for ensuring the safe and reliable operation of motor-driven equipment. When dealing with electrical equipment, it's paramount to adhere to safety regulations and consult with qualified electricians. Improper installation or maintenance can lead to electrical hazards and equipment damage. Motor starters generally have three main types. These include across-the-line starters, reduced voltage starters, and solid-state starters. Each of these three types have subtypes. Across-the-line starters connect the motor directly to the power supply, providing full voltage to the motor. These starters are simple and inexpensive but result in high inrush current during startup, typically 6 to 8 times the full load current. Reduced voltage starters, as mentioned, reduce the voltage applied to the motor during startup, thereby reducing the inrush current. These starters include autotransformer starters, reactor starters, part winding starters, and wide delta starters. Solid-state starters use solid-state devices, such as silicon-controlled rectifiers, to control the voltage applied to the motor during startup. They offer smooth starting and stopping, adjustable acceleration and deceleration rates, and overload protection. Motor starters are essential components for controlling electric motors, providing protection and ensuring efficient operation. Selecting the right motor starter depends on factors such as motor size, voltage, application requirements, and cost. Proper installation, maintenance, and troubleshooting are crucial for reliable performance and safety. Always consult with qualified electricians when working with electrical equipment. The selection of a motor starter also depends on the specific application and the motor's characteristics. For example, motors used in applications that require frequent starting and stopping may benefit from a solid-state starter, which offers smooth and controlled starting and stopping. Motors used in applications where the inrush current needs to be limited may require a reduced voltage starter. The cost of the motor starter is also a factor to consider. Across-the-line starters are generally the least expensive, while solid-state starters are typically the most expensive. When installing a motor starter, it is important to follow the manufacturer's instructions and all applicable electrical codes. The motor starter should be installed in a location that is clean, dry, and well ventilated. The wiring connections should be tight and secure. The motor starter should be properly grounded. Regular maintenance is essential for ensuring the reliable performance of a motor starter. This includes checking the wiring connections, cleaning the contacts, and inspecting the overload relay. If any problems are detected, they should be addressed promptly to prevent further damage or failure. Troubleshooting a motor starter involves identifying the cause of the problem and taking corrective action. Common problems include blown fuses, tripped circuit breakers, and faulty components. A multimeter can be used to check the voltage, current, and resistance of the various components in the motor starter circuit. When working on a motor starter, it is important to take safety precautions to prevent electrical shock. Always disconnect the power supply before working on the motor starter. Use insulated tools and wear appropriate personal protective equipment such as gloves and safety glasses.